Okay, the top of the mountain here for us. Our last problem, solving trigonometric equations. The top of the mountain. So, this is like the perfect review of everything we've done in this unit, kind of. Here's our process. Try to write all terms as variations of sine, cosine, or tangent. No mixing and matching. Rut-row, that's my Scooby-Doo. Rut-row. Mixing and matching. That's no good. I don't want sines and cosines in the same equation. This would be a very bad situation for us. So how do we handle this? That's why I said it's a very good review of everything we've done in this unit. Okay? Because I would be able to solve this problem if it had only cosines. Like, for example, like if this was cosine squared, that would be okay. But the fact that it's sine squared causes me problems. So the question becomes, is there a way to make this sine squared a cosine squared? Is there a way to get rid of the sine squared but include a cosine squared in its place? And that's why I'm saying this is a great review of everything we've done in this unit, because think back to when we were simplifying and verifying. There is a way to replace sine squared with cosine squared. What would it be? It would be cutting this out and in its place putting 1 minus cosine squared. One of those Pythagorean identity manipulations and substitutions. How about that? Now it's cosine squared, which is how we want this to look. So we're using an identity to write this problem only in terms of cosines. How many times did we do this substitution when we were simplifying and verifying? Quite a bit, okay? Now we're using it to help us solve, putting this in a format that we are comfortable with. Now, and again, don't misconstrue this. I'm not trying to verify that this is the same as this. I'm still solving, okay? But I had to make that one substitution to get it in terms of just cosine. So now I can say, yeah, okay, I did that, check mark. Okay? Now we go here. Does the new equation have a squared trig term and a non-squared trig term? Does this equation have a squared trig term and a non-squared trig term? Indeed it does. Yes. So what do? We set the equation equal to 0. Now, what's that going to look like? Because it's definitely not equal to 0. So I need everything to be on one side of the equation. Okay. The first thing we should probably do to clean this up is distribute the 2 into that quantity. Now it's 2 minus 2 cosine squared x equals cosine x minus 1. We're just trying to quote unquote clean it up, simplify it, and move it all to one side. Now, here's where you got to have a little bit of foresight. You got to see into the future a little bit here, okay? I can do that for us. That's part of my job. Now, we see the squared term. We see the non-squared term. How many problems have we done like that? We did this one. Okay? We did this one. Sorry. We did this one. All these times that we get these squared terms, these non-squared terms, and these floating constants, these trinomials, which is where I think this problem is headed, the leading coefficient was always positive. So when I look at this problem, stay with me, right? Have the foresight, have the focus. I'm going to put this equal to 0. And typically, we like to move this stuff over to the left side. I don't know, maybe that's just my preference. I don't know what your preference is. But My preference is to have it all on one side here, set equal to 0. But if I do that, this is going to be negative. And I'm not okay with that. I'm not okay with negative leading coefficients when I'm supposed to be factoring. Okay? Like if I said, which one of these would you rather factor? Negative 2x plus x minus 1 or positive 2x minus x plus 1? Which one would you rather factor? I would assume most of you would pick this one. Okay? Because that's a negative leading coefficient, which is kind of scary. That messes with things. So, long story short, which is a great song, by the way, Long Story Short by the Avett Brothers. You guys familiar? Have I told you about that before? No? It's a great song. You should look it up. Long Story Short by the Avett Brothers. Anyway, I'm not going to move that stuff over to here because that would give me a negative leading coefficient. I'm going to move this stuff over to there. That's what I'm going to do. So, first thing I'm going to do is subtract 2. Subtract 2. We have negative 2 cosine squared x equals cosine x minus 3. And in fact, sorry, I think I have a misprint here. Not a big deal. Let's do this. Let's make this a positive one. Let's make that a positive one. So now, instead of this being negative 3, it's negative 1. So this problem should have started with a plus sign. That doesn't change anything we've done up to this point, but I'm just now realizing I think that should probably be a plus sign. Okay? No harm done. So instead of that being a minus 3, it's a minus 1. No harm done. Now, I'm going to move this over. I don't move this by dividing it, I move that by adding it, right? Making this a 0, so I add the opposite of this over to this side. Now it's 0 here, and then on this side I have 2 cosine squared x plus cosine x minus 1. A positive leading coefficient. That's what I want. Okay? Now, if you really wanted to, right? If you were like, I don't like this over here. I like it when that's on the left side. Okay, fine. Just switch the 0 and that whole thing. Doesn't matter, right? It's reflexive. So, now we have it set equal to 0. Yay! Check mark. So factor it. And if you're looking at this and you're like, I still don't get this factoring thing, Mr. Jackson. I still don't understand how I'm supposed to factor that. Just go off to the side, and instead of cosines, give yourself just some space like this and say, okay, what if it was the letter A? If it was the letter A, it would look like that. 2a squared plus a minus 1. So we're basically cutting out the cosine x and putting an a in its place. And I'm cutting out this cosine squared x, and I'm putting an a in its place here. And then ask yourself if you can factor this. And as I've said before, I sure hope so. Right? We have a prime leading coefficient of 2, so the 2 has to go with one of these a's. And then I need a product of negative 1 from these two numbers. This space and this space have to multiply to be negative 1. Well, that's got to be a positive 1 and a negative 1. We just don't know in what order. Where does the positive go and where does the negative go? I'm going to put the positive 1 here and the negative 1 there. And then we should test it. We should test it just to make sure we put those in the right place. Okay? Like 2a times 1 is 2a. Negative 1 times a is negative 1a. So that would be 2a minus 1a, which we get 1a from that. Okay, good. So I know that I set that up correctly. That's a test that you can do maybe in your head, but if you can't do it in your head, write it all out. Check it after you've done that factoring. Okay, so this is our margin work. This is our brief little aside to make sure that we can factor this, and we can. So now when we come back to the problem at hand, instead of a's, I write cosine x's, because that was the substitution that we put in here. So the exact same format as this, 2a minus 1, 2 cosine x minus 1, a plus 1, cosine x plus 1. Done, factored, check mark. Set each quantity equal to 0. So, we have 2 cosine x minus 1 equals 0. And we have cosine x plus 1 equals 0. And then we solve each one of these separately, as we've been doing this entire topic. We add 1 to both sides, we divide by 2, and then we ask ourselves what angles have an x-coordinate of 1/2. And if you have a unit circle, you could look around and find the x-coordinates of 1/2, and you would see that they are at pi over 3 and 5 pi over 3. One of them is in quadrant 1, the other one's in quadrant 4. The x-coordinates have to be positive, so if my elbow is the origin, the only positive x-coordinates are in quadrants 1 and 4. Okay? And I think we just did this in the opener, right? Cosine x equals -1. So x equals the angle that has an x-coordinate of -1, which is pi. So we get 3 solutions to this problem. This is a great review because it involves Pythagorean manipulation and identity manipulation and substitution, which we did for like 3 weeks, right? And it includes it in something that we've been spending the last 4 days on, solving an equation. It's a good place for us to finish up here, if you ask me. All right? Ba-doo-doo-doo.